So this is section 9.3, separable equations. So the precursor to this section is called separable variables, or solving initial value problems. That's basically what this section is all about. We're going to be solving for the c value when you integrate, right? So remember, if we take the integral, for example, of a function dx, this is that integral plus the c value, right? So we're going to figure out, okay, what's that c value that separates each one individually, and that's what we're going to be dealing with, is how to find that actual function, including the c value itself, that constant. Okay, so when it comes to this type of portion, is we're going to have the differential proportions. We'll figure out dy dx equals two different functions, and then from there we're going to break them apart. So in other words, we're going to bring all the y's to one side and all the x's on the other side. So in other words, we bring this here and bring this one to the other side. Okay, so that way we have all the y's and all the x's on one side, and then we're going to take the integral of both sides, respectively, of either x and y, respectively. Okay, and that's pretty much how we're going to deal with this kind of section. And then from there, we're going to solve the initial one, because going backwards when it comes to it. Okay. So the best way I can think of it is literally just try an example out, right? So what I mean by we want all the x's and y's on one side is, notice this is dy dx, and it's x to the fourth y squared. So in other words, let's bring this one to this side and then dx to the other side. So in other words, just cross multiply, right? So if I cross multiply, we now get y squared dy is equal to x to the fourth dx, right? Just literally just cross multiply. And now remember, we want to solve for it. So now the opposite of derivatives, right, dy dx, is take the integral of both sides with respect to its original portion. So for example, here we're taking respect to y, over here we're taking respect to x itself. Okay. And this integral is not too bad for both portions, right? So this is going to be y to the third over 3 plus c, and on the other side, same process. So we x to the fifth over 5 plus c. Okay. And now what we want to do is essentially solve for x, right? Solve for y. So we're just going to bring this over now. If minus c, again, we don't know what it is. It could be bigger or smaller, but we're just going to keep it as the c value itself. Okay. So essentially, this ends up being just like this, plus some other c. Most people like c1, but it really doesn't matter. It's just some random constant we're going to be finding out later on in the course, or later on in this example. So now we multiply everything by 3. And then 3 times c, again, is still a constant, right? So it really doesn't matter at that point. And then finally take the cube root of both sides. So now we have y is equal to the cube root of all of this. Just like that. Okay. So basically, essentially, we're done at this point, right? Remember, we're going back last class, right? When it's solving for a system, you're done. We take the derivative or the antiderivative, you're done. But again, the whole point of this portion now is figuring out what the c value is going to be, and that's using this initial condition here. So what this is saying is, if x equals 0, y equals 2. And that's how we're going to solve, let's see, just going backwards, just plugging them in, essentially what we deal here. So for example, in this case, it's going to equal 2, so y equals 2. And everywhere I see an x, I'm going to plug in 0. And then we're just going to solve for c there. So right, this whole goes to 0. So we have 2 is equal to the third root of c. So now just solving for c, right? Cube both sides. So 2 to the third equals c. So therefore, we know the constant is going to be 8. That's our actual constant. So our actual function we started with, right, before we did all of this once, or the original function we started with, is y equals the third root of 3x to the fifth over 5 plus 8. There we go. So that's how we solve for the initial condition or initial equations of them. Okay. And it's about the same thing, right? It's always going to be roughly the same kind of template. You always have dy dx on one side, and you solve for x and y respectively. Okay. So let's try a couple more down the list here. Okay. So same process. We have x and y, so we're going to cross multiply here. So it's going to be y dy is equal to x sine of x dx, with a y of 0 equaling -1. Okay. So you notice, right, now I can show you, we can do lots of stuff, all the other integral properties we had before comes into place here, because notice here is integration by parts, and this isn't, right? This is a simple just integral at this point. So integral, this is y squared over 2. However, on this side, it's integration by parts, right? So we're going to let u equal x, so therefore du is equal to 1. dv is sine of x, so therefore the integral of sine is going to be negative cosine. Okay. So again, you guys remember integration by parts, it's v times u, so minus x cosine x minus integral of v du, so minus minus makes positive, integral of cosine x dx. Okay. And now we just integrate, right? So this ends up being y squared over 2 is equal to negative x cosine x. And integral of cosine gives you positive sine plus RC. Okay. And now, again, solving for y, so multiply everything by 2. And then taking the square root of this entire stuff here. Okay. And now, again, just like last time, we write down our initial condition. So this time, when x is 0, we get y equals -1. So this whole thing ends up being -1. And we plug in 0 in for x, so that goes away, right? Because 0 times anything goes away. And your sine of x, is, if you notice, is also what? If you guys remember, sine of x is also 0, right? If you go in a unit circle. So we have -1 is equal to c. Well, that's kind of interesting, because if you take the square root of everything, so square both sides, right? So c is equal to 1. All right, so therefore we have our equation. Now, here is the interesting part, though. If I would plug in the same situation, plug in 0, goes away, it should be -1. We have a problem. That is not true, right? So even though we squared it, we got 1, it doesn't make sense, right? We don't get -1 out, right, when it comes to it. So therefore, this actually does not exist for this portion. So really, really horrible, right? So we did all the work, and it really can't to find a value of c that makes this work. Okay. So interesting stuff there, right, when it comes to it. However, if we just change this to 1, then it would work. It's crazy how if you just change one single number, it changes everything, right, when it comes to it. So if y the function equals 1, it would work. But if it's -1, it doesn't work. So pretty interesting stuff when it comes to it. So the answer for this question is it does not exist. There's no such function that would work when it comes to it. Okay? So there's no such c value that would make this true no matter what. Okay? All right, so let's keep going to the next one. So remember, it doesn't have to be x and y all the time. It could be any variables we're looking for, right? So we're just solving for the initial value problem in general. Okay? So in this case, we want to figure out with respect to p. So notice it's p here, so you know it's going to be with respect to p, just like here. Since we have y of 0, we know we're going to be solving for y. So in this case, we're going to be solving for p itself. Okay. Okay. All right, so let's see. So we have to get rid of this stuff somehow, right? So let's see. Well, let's rewrite this. This is the same thing as p to the 1/2, t to the 1/2, right? If you just break it up. Okay, and therefore now we could just cross multiply, right? So in other words, bring this down. So we have dp over p to the 1/2 is equal to t to the 1/2 dt. Okay, so if we take the integral, and again, I'm just going to put this at the top, make it easier. So it comes to a negative 1/2. Just take the integral of both sides, right? So integral of this is add 1, so add 1/2. So this is p to the 1/2, so 2. Over here, add 1/2. That's going to be t to the 3/2. So this is 3 over, 2. 2 over 3 plus c. Okay. And now again, now we solve for p in this value. So in other words, divide everything by 2. So this ends up canceling. So we get t to the 3/2, just 3, plus c. And then finally taking squaring both sides, right? That's what we get rid of half. So p is equal to squaring both sides, exactly this. Squared. Okay. And now we plug in our initial value. Right? So when t is 1, p is 2. So this is 2, and t is 1, so t to any power is just 1. We get that. All right, solving for t, so squaring both sides, or square rooting both sides gives you square root of 2 is equal to 1/3 plus c, and bring it over, so c is equal to the addition of radical 2 plus the 1/3. Okay, so therefore, if we don't use calculator, our equation is going to be exactly this. And there we go. There is our equation with respect to p. Right, so last one down here. So this one with L, so that's going to be the one we're going to be solving for. So let's see, so we're going to bring L to one side, bring everything else to the other side. So bring this down gives you dl over L squared. And on the other side, bring this is going to be W natural log of t dt. And same thing, I'm going to bring this to the top. Okay. Gives us that. So one side, not too bad, right? Integral of this is going to be add 1, so be L to negative 1. Okay. Equals on this side, again, integration by parts. So I'll let you guys do that integration by parts since we've done this actually a lot of times. So I'll just give you guys the end result. Okay. And then we just solve for L. So minusing both sides. Okay. Now this is the tricky part. Since it's 1 over it, so we get L by itself is just 1 over this whole concept here. And now finally, we solve for C value. So we plug in negative 1 for L and plug in 1 in for T. So negative 1 for L. And this whole thing is going to give us, and we plug in 1. for t. So natural log of 1 is actually 0, so all that cancels. And this is going to give you w plus t, or sorry, plus c. All right, so multiplying gives you negative w minus c equals 1. Bring it over. So we get negative c is equal to 1 minus w. So therefore c is equal to w minus 1. And there we go. So now let's plug everything together. So our final answer is going to be there we go. Just like that. Okay. And that's separation of variables, where we're just going to break up. So what it means by separation of variables is just breaking this up, right? Cross multiplying. That way we have one variable on one side, one variable on the other side, integrate both sides, and then solve for the initial value problem there. And that's it.